Good morning and welcome to this first presentation in a series of webinars showcasing our IP portfolio evaluation capabilities. This presentation will take about 20 minutes, followed by a Q&A. You can ask questions anytime using the chat box on your right. Why are we doing this presentation? As a leading provider of intellectual property analytics, we have developed a new set of modules that can help our customers better manage their patents portfolio, from scouting new technologies to the monetization of it. To perform an effective global technology scouting activity, you will need to use a powerful and comprehensive search tool, advanced analytics, and methodology that enables our clients to find and acquire new technologies, products, and the related intellectual property. Today, we are pleased to share with you how our solution can help you elaborate technology scouting and licensing projects efficiently. The agenda of our presentation will be as follows. First, we propose to show you how our search software Orbit can help you identify patents in your chosen domain. Then, we will evaluate technologies that are relevant to your technical needs and business. And finally, we will provide you with more transparent and tangible information to support your decision-making process for acquiring or in-license these patents. Sorry. You may have seen this slide before that illustrates Questel complete offer covering the complete innovation life cycle. The blocks that are in red on the left of your screen represent the two modules that we will highlight today. I am now pleased to introduce you my colleague, Eugénie Mérigeau. She is a senior consultant on energy and materials, and she's based here in our office in Paris.
So good morning, everyone. I'm going to show you the possibilities of Questel solutions, especially how you can save a significant amount of time when performing a technology scouting activity. We have chosen to illustrate a use case scenario in the field of lithium-air batteries. The lithium-air battery is one of the most promising technologies that could possibly improve the autonomy of electrical vehicles. This is the reason why there is a growing interest in performing R&D and inventive activity with this topic. In order to fully comprehend the potential need of a company performing technology scouting, we developed the following scenario using public data from Orbit. The company Robert Bosch, active in the field of batteries and who already have built a lithium-air battery portfolio, might want to improve their portfolio using a carbon-based material, the graphene.
Okay, Eugénie, so could you describe what would be the first step in your process?
Yeah, sure. The first step is to search relevant patents that match the need to improve lithium-air batteries, and graphene is one of the most cutting-edge material that can be used in the field of lithium-air batteries. Thanks to its, among other things, conductivity and mechanical properties. This will be the type of patents that we are looking for.
All right. And how is Robert Bosch going to identify the relevant patents that they need?
Well, here, a similarity search followed by keyword search related to the topic will need to be run. From here, we retrieve a first large and unspecified set of patents. The second step consists of computerized assisted reading, which combines word highlighting, keyword in context, and concepts. Here we do a relevant highlight of keywords such as lithium air, lithium oxygen, and batteries. The third step of the search strategy represents the quick manual review and removal of the non-relevant patents. Surely one of the most time-consuming of all steps. It may take perhaps a half a day or a full day, depending on the topic to perform. But these three steps are vital and need the searcher's full attention. as there really is a need for human evaluation. It goes without saying that the final results of the technology scouting process depend on this critical database creation. We now have our set of lithium-air patents. With this set, we can run an analysis and obtain trends, such as the number of patents filed per year. Robert Bosch is right to look at this technological field, as the graph shows a strong increase in patent filings in the lithium-air field during the last years. So considering Robert Bosch's objective in this scenario, it is interesting to break the patents down into types of applicants. The graph you see here shows the potential of finding technologies from academic or from small entities. These two types of entities are more likely to license their asset than a large company. In the former step, we identified a portfolio solely focused on lithium-air. A technology scouting process is like a funnel. We need to go deeper within this portfolio to only extract the graphene patents.
Well, tell us a bit more about how do you find those graphene patents?
Well, rather easily. Concepts are automatically extracted during the previous analysis step. By grouping the concepts containing the word graphene, we can focus on relevant patents. As shown in the word cloud here, the results indicate that there are 72 patents using graphene.
Okay, so now we understand that you found 72 patents. What about the assignees?
Okay, well, let's look at the owners of the patents and list the patents by top technology players in lithium-air. To clarify, we colored the graphene patents in red. You can clearly see the Robert Bosch competitors in this topic. Interesting to note that large industrial players do not own a lot of graphene patents, and that Robert Bosch already owns one patent in this topic. As there are not many industrial players in the field of graphene, it is an opportunity for Robert Bosch to differentiate their portfolio. So now we have seen an overview of who owns lithium patents, lithium-air patents, and overall these are large entities. Generally, these large entities would not sell off their patents to a direct competitor. And based on this insight, the set of patents is split in several categories. Those owned by the large industrial players with little chance for in-licensing, but which further need to be studied in order to identify skills. And the inventors that lay behind the patent and that can potentially be hired. The table you see now does not show the full list as it counts 52 patents. The second category of these 52 patents represent patents from academia and small entities. When we look at them, we can make a final cleanup. We see that 4 patents are filed between a university and an industrial player, and 1 patent is already dead, so we remove these. Let's see where we stand now. So we started with a set of 632 patents, and we have trimmed this list down to a set of 47 graphene patents. And these 47 patents will now be analyzed. We are ready to run our technology scouting software module.
All right, Eugenie, could you explain how that module works, technology scouting module?
From our basic 47 graphene patent set, the technology scouting module will give an overview of the opportunities and rank the patents according to 11 potential scouting metrics. These These metrics represent 11 most relevant criteria in a patent in a scouting activity, such as generality, age of the patent, radicalness, forward citation, just to name a few. From this slide, the following steps need to be taken. Firstly, the list of 47 patents to analyze need to be uploaded. Secondly, the assignees, in order to obtain more accurate results, need to be regrouped, as sometimes assignee names are not normalized. Or we may want to regroup recent acquisitions under one parent company, for example. Once these two steps are validated, the result page appears. This slide here shows the first result after a run through the technology scouting module. Please note that it is not a black box. This means that each metric and parameter can be fully adjusted according to your own industry needs. What we see here is a selection of the most relevant patents for technology scouting. You can see that only 9 patents appear among the original 47 selected.
Great. Could you explain a little bit more in details, please?
Okay, let's go deeper into the results to answer this question. This slide gives the whole ranked list of patents according to the potential as technology scouting opportunities. This list has been categorized into 4 levels and colored.
Okay, could you explain a bit the signification of those colors?
Yeah, sure. The patents, colored in gray, here, represent unclassified patents. And this could probably be due to their young age. As you all know, young patents are not cited yet and have little or no proven track record. But there may be in these patents a technology that may fit with Robert Bosch's needs. Additionally, these patents, as they do not have an impact yet in the field, may be cheaper to acquire, and on the sideline, it is obvious that should one want to identify the golden nugget, one needs to read these patents thoroughly. The green patents, highlighted here in red, have a high potential. They are already impacting the field, and if added to the portfolio, may improve it. Based on these results, Robert Bosch should acquire these 2 green patents, but we decided to add some more human input to this result. Running the patent list, we can break it down in 4 categories. These categories are related to the relevancy of the topic. A 4-star patent represents those where graphene lies in the core of the technology described in the patent. And those with only 1 star represent a patent mentioning graphene among other materials, for example, the improvement of connectivity.
And how do you go about the classification of the patents?
Well, Orbit work files allow one to upload a list and classify them manually, classify each patent manually. Finally, the patents of most interest are those that are not ranked at the top. We see that we need to compromise between the ranking obtained thanks to the metrics and the relevancy of the description of the patent. All right, thanks to the technology scouting module, we now identify 3 patents potentially interesting to acquire through the licensing-in or acquisition. The next step is to take the decision. The licensing-in module will help us to do this.
And how does the licensing-in module complement the technology scouting module we just ran?
Well, the licensing-in module is based on 45 normalized metrics used to compare the portfolios to a given environment. In this case, we want to evaluate the complementarity of these 3 patents to the existing Robert Bosch portfolio. As we mentioned previously, to do this evaluation, we will use 3 sets of patents. The the portfolio of Robert Bosch that owns 23 patents in lithium air, the selected patents, and finally, the set we defined in the first part of this case. Do you remember the one when we did the lithium air patent landscape? Our three sets are uploaded in turn in the module. As done previously, we regroup certain assignees. We run the licensing-in module to obtain the results, which are shown here in a series of 3 radar charts.
But what are the key information we can extract from these charts?
Okay, well, in all 3 of these charts, the blue line corresponds to Robert Bosch's portfolio, and the red line corresponds to the analyzed portfolio to acquire or to license. The position on each colored line is related to the value of each portfolio. This value is reached by the relevancy of the portfolio for each metric. The further away from the center of the line lies, the better the portfolio value is.
Okay, we understand that the lines represent the 2 portfolios we are analyzing, but could you explain a little bit the different colored areas?
Okay, yeah, the colored areas are defined by the lithium air environment. These areas are our starting point to evaluate the Robert Bosch's portfolio and to compare the portfolio to other players in the field. When Robert Bosch's portfolio is in the orange area, it means that the corresponding metric is weaker than the majority of other assignees in the lithium air field. When Robert Bosch's portfolio is in the yellow area, it means that the corresponding metric is better than the majority of the other assignees. When Robert Bosch's portfolio is located in the white area, finally, its position is outstanding compared to the other players.
Okay, that's clear. What's the conclusion here, considering our 3 patents?
Well, here the chart regroups all the metrics related to the legal validity of the portfolio and shows that the addition of the 3 identified patents, which I recall are in red, can really improve the characteristics of the Robert Bosch portfolio. We will now focus on the technical metrics, and these can be read the same way than the previous chart. Once again, the 3 patents will improve overall the Robert Bosch portfolio if added. And Robert Bosch's blue line shows that it's better than the average in the field. Nevertheless, the 3 patents will allow them to surpass the yellow area for a certain criteria. Finally, one last chart in this area, and it concerns the geographical coverage.
Why do we look at the geographical coverage?
It's important to have the geographical coverage in line with the market you are targeting. In this case, the fairly low values for the geographical graph are linked to the very small size, I recall only 3 patent families, that impact the whole result. When we look at the 3 patents specifically, one only covers the USA. This may make it difficult to protect the battery market. The 2 other patent families have been extended to cover the whole battery market, including the US, China, Europe, South Korea, and Japan. Interesting to note that when you wish to acquire patents, you will need to know your potential competition. This graph here shows you a list of companies citing 1 or all 3 patents you are targeting. Okay, we have performed a comprehensive search. We have applied advanced analytics and methodology in order to potentially scout 3 patents. Each patent will need to be complemented by other assets, such as trademarks, copyrights, etc., in order to build a solid business case. We have now come to the end of the presentation, and we'll start with the Q&A session shortly. We have collected your questions during the presentation and have grouped them in thematic order.